I'm busy doing a lesson on how you mark the osmosis practical and what you must always have and what you must remember. So we look at the experiment, and most of you saw this, that the girls a few years ago had 4 days to do the experiment. And the most important thing that you need to know is design an experiment. This number one is important because this is where you're getting your variables. Design an experiment that investigates osmosis through potato cylinders in different types of solutions. And it must be a fair test. So here is where you actually get your variables. So the instructions are extremely important. Now, the girls had to write this are the following things. They had to write aim, hypothesis, aim, apparatus, method, the variables, a table, a graph, discussion, conclusion, and evaluation. Now, if you go to the memo wanted many things. Now, I always start teaching the variables. The dependent variable is what you're measuring. So here in this case, I know most of you said mass, length, width of the potato cylinders. Yes. But I want you to remember, if you are ever going to be measuring any structure or anything that you're investigating before and after, and if there's a change in that object or structure or specimen, there you must have the word changes in your answer. So you can see here, those that wrote changes, they got 1 mark more. If you said mass, length, width of the potato cylinders, you only got 1 mark. So you have to be very specific. I've been teaching you all along types of solutions, okay? But different types gets you 1 other mark compared to types of solutions. But always you say different types of solutions. You can see that is what separates those from those who remember and those who just forget. Fixed variables are variables that must be kept the same. Same number of potato cylinders, same time the potato cylinders are kept in, equal size potato cylinders, same amount of the different solutions, or it could have been same amount or volume. It's the same thing, okay? So it should have had a slash there. Same temperature, the potato cylinders are exposed to, same amount of light, the potato cylinders are exposed to. So make sure that you're very specific. Don't just say same temperature, right? Same temperature, the potato cylinders are exposed to. Same amount of light, the potato cylinders are exposed to. Be very specific. So now these are your dependent variables and your independent and your fixed variables. Yes, we also accepted same species of the potatoes, okay? Because of course you get different species of potatoes as well. Okay, so that is now your variables. Once you have your variables, you can go back and write your hypothesis. Now you could have said, using if and then, if the potato cylinders are placed in different types of solutions, then the size of the potato cylinders will change or be affected. If potato cylinders are placed in different types of solutions, then osmosis can take place. That's if you want to use if and then. Or you could have said different types of solutions will lead to osmosis, or you could have said will not lead to osmosis at different effects. Okay. But you can see here, those are your variables. Your aim must start off with the word to determine or to investigate. And then you must have that the size of the potato cylinders will change or be affected in different types of solutions. Or if you used osmosis, to determine if osmosis will occur when potato cylinders are placed in different types of solutions. Here, your apparatus must be bulleted, and it's all the apparatus or equipment that you use, like the sizes of the potato cylinders, beakers, what solutions you use, the scale, the ruler, potato borers. You could have also added in here pen and paper, okay? And remember, your apparatus and chemicals must be bulleted. If you look at your method must be listed, meaning 1, 2, 3, 4. Do not write step 1, step 2. Third person, there's no I or me or my, and logical. You first collected the potatoes, then you measured the length and the width, then you measured the solutions, and then you put the potatoes in, right? Always end off with record their results, right? This is your method. This is logical. We've just done the variables. Your results. Your results must be in one table. And if I wanted the results before and after, of course, I want to see it as a heading, before and after. Measurement of potato cylinders before, after, there's potato cylinders. Yeah, I only use 3 solutions. And there you have the mass, length, width, and then the units. Okay. If you drew 2 tables, I only mark the first one. The graph, of course, the best and the only correct way graph is a bar graph. Then you must have a heading with different types of solutions and mass in the heading. Your scale, you must have 0 at the origin. So if I'm quickly going to draw this, So you have 0 there. You have a heading with different type solutions and mass. Here, your scale line. Your independent variable was different types of solutions. And here, mass of potato cylinders. And then space bar space. So, and then you're heading with the A bar graph showing the mass in the potato cylinders in different types of solutions. Okay. So that's what you should have had is a bar graph. And now your discussion is extremely important. That's where most of the marks come in. And whenever you're going to be talking about in the future, any experiment, like here now you're talking about osmosis, you must tell the person what osmosis is. See, osmosis, where water moves from a high concentration to a low concentration through a semi-permeable membrane. And you tell me that the potato has a semi-permeable membrane. If you get an experiment on transpiration, tell me in your discussion what is transpiration. And here I explained the discussion. So I'm going to explain it here. So I'm going to, if it was me that did the experiment, I would have done the experiment with tap water. So here, you cover the potato with tap water. And there's your potato. Your tap water has mostly water molecules, so that's a high concentration of water. The vacuole has sugars and salts, so immediately that decreases your concentration of water. Is there a gradient? Is there a high and a low? Yes. And remember, for osmosis to take place or transpiration to take place, you need a gradient. And then water moves from the tap water into the potato, and that is endoosmosis. And because the water moves in, the potato will swell. Okay, so that's what you should have had for your tap water. Then you could have done your, I also would have used the 10% of sugar or salt solution. There's your potato, let's say 10% salt. Immediately there's more salt than water, so there's a low water concentration. Here there's more water because there's more water in the vacuole. Is there a gradient? Yes. So water moves from a high concentration to a low concentration. Water moves out. That is exosmosis, and the potato will shrink. Okay. And the last one, if you ever did this experiment at home or you did it in class, never use the one with the 2%. The 2%, unfortunately, and maybe 2%, salt or sugar. It had a high concentration of water. It had a similar concentration of water to the vacuole. So there's a high concentration in the vacuole, there's a high concentration of water in the beaker. There's no gradient, so no water moves out. This is known as an isotonic solution. So no water moves out. So you wouldn't have seen the change. So that's why if you're going to ever do an experiment, use 3 where you're going to get definitely different results. And then of course, if you use distilled water, you could have said distilled water is your control to compare with your experiment to prove that osmosis does take place in your experiment. And then you can mention that in your discussion that this was the control, whichever one you chose. And then yes, the conclusion, the size, the mass, the width, the length of the potato cylinders are affected when they're placed in different types of solutions, or osmosis does occur when potato cylinders are placed in different types of solutions. Your evaluation, of course, we only did the experiment once. If we did it many times, we could have increased the reliability, and we only used 1 potato cylinder per solution. We could have increased the sample size, such as the potato cylinders, so your experiment is more fair. Okay, ladies, I hope that helped you and you did well and you learned from your mistakes. Thank you.